Hello there. Let's look at velocity equation for a simple harmonic motion. We know that displacement x is given by a sine omega t. It can also be x equals a cos omega t. We know based on one of the previous videos that based on when we start measuring in the simple harmonic motion, it can be sine omega t or cos omega t. Let's take sine omega t for this velocity equation. If we differentiate x, we get velocity, which is differentiation of sine omega t is cos omega t, and we have no omega for the omega t. So a omega cos omega t. Let's call this equation 1 and this as equation 2. We also know that sine square theta plus cos square theta is 1. So we can write cos theta as plus or minus square root of 1 minus sine square theta. Let's plug in omega t instead of theta here. We get cos omega t equals plus or minus 1 minus sine square omega t. This can be put in equation 2. If we put, let's call this equation 3. Using 2 and 3, we get velocity, which is nothing but differentiation of displacement, rate of change of displacement is plus or minus a omega square root of 1 minus sine square omega t. Let's call this equation 4. But from equation 1, we know that sine omega t is x by a. So using 1 and 4 equations, we get b equals plus or minus a omega square root of the sine omega t is x by a. So it becomes 1 minus x square by a square. From this, we can further simplify to get v equals plus or minus omega. Let's take the a inside. Let me use a color here. Let's take the a inside the square root. It becomes a square. When a square goes inside the square root, the first term becomes a square. 1 becomes a square. The second one becomes x square because a square gets cancelled out with the denominator. So it becomes a square minus x square. This is the velocity equation we get, where if we know the angular frequency omega, the amplitude a, and the displacement x without knowing the time, we can find out the velocity. Thank you.